This short video presentation has been developed by Ford Climate Control Operations to assist Ford and Lincoln Mercury dealership technicians to better diagnose and repair customer concerns about air conditioning performance. Over the past few years, too many of these customer concerns have resulted in replacement of the evaporator core under warranty. When these evaporator cores are returned to Ford's climate control operations for testing, over 60% of the cores tested show no defects whatsoever. These evaporator cores are being needlessly replaced. Of course, the worst aspect of this situation is that since a properly functioning component was replaced, that same 60% of vehicles are not being repaired correctly. And those customers will have to come back to have their vehicles serviced again. The purpose of this video is to reiterate the need for closely following the diagnosis and service procedures outlined in your Ford or Lincoln Mercury service manuals. Following the service manual diagnostics carefully and in sequence will reduce unnecessary warranty repairs and customer comebacks. We'll also look at two different methods of leak testing the AC system. We will show you the correct method for vacuum testing the evaporator core. And finally, we'll highlight the correct tools needed to perform these procedures. When a vehicle comes in with a poor AC performance concern, first, perform a visual inspection under the hood, as outlined in Inspection and Verification in your service manual. Check the compressor drive belt, AC electrical wiring, and so on. If the vehicle is equipped with electronic climate control, initiate the onboard diagnostics and check for diagnostic trouble codes in the vacuum fluorescent display window. If DTCs are present, refer to Service Manual Section 1203C for service strategies. If the vehicle is equipped with manual air conditioning, refer to the diagnostic procedures in Section 1200 of the vehicle's service manual. No technician can keep up with all the new technology and designs which come out every year, and these diagnostic checks may suggest a number of items you haven't even thought of. For instance, one of the possible causes for poor AC performance, which is listed in your service manual, is a stuck or inoperative temperature blend door, or its electric actuator. Any number of problems in the air management system can also cause poor AC performance. You can't just assume it's the result of a refrigerant leak. Your service manual diagnostics will lead you through a step-by-step examination of the AC system. By covering all your bases, you can ensure that the vehicle is repaired right the first time. If you've verified that the AC system is low on refrigerant, you'll need to test for leaks. So let's take a look at refrigerant leak testing. Most of you have used electronic leak testers before, so just a few points. Make sure that the tester you are using is calibrated for the refrigerant you are testing. Some leak detectors will only detect R134A refrigerant. Some are designed to detect only R12, while some will recognize both. Be sure you're using the correct tool for the vehicle you're working on. Following the tester manufacturer's instructions, pass the tester near and around all refrigerant line fittings. Also, check the compressor fittings, center seam, and the shaft seal for refrigerant leaks. Be sure to pass the test probe along the underside of all points being checked, since refrigerant is heavier than air and so tends to travel downward. Do not use electronic leak detectors in the vehicle's interior. Airflow from the blower motor and other chemical odors from the vehicle can cause false readings. Another method you can use to check for refrigerant leaks is with dye and a black light. As of the 1995 model year, all Ford Motor Company vehicles, except the Mercury Villager and Ford Aspire, come with a tracer dye added to their refrigerant systems. Carefully check the refrigerant line connections using the black light, in much the same way as you use the electronic leak detector. For pre-1995 vehicles, you can also add a small amount of tracer dye to the AC system should you want to use the black light leak test. Remember to use the proper dye with the proper refrigerant. If, after reviewing system diagnostics and checking AC components and fittings for leaks, the evaporator is still suspect, refer to Section 1200 of the Service Manual. In Section 1200, your Service Manual diagnostics call for vacuum leak testing of the evaporator core. So let's take a look at that procedure. First, discharge and recover the refrigerant using an AC charging station. Operate the charging station according to the manufacturer's instructions. Then, disconnect both the liquid line and suction accumulator dryer from the evaporator core. Do not attempt to leak test the evaporator core with the suction accumulator dryer attached. The desiccant in the suction accumulator dryer will cause false readings. The tools you'll need for the vacuum test are a manifold gauge set, a vacuum pump, and line fitting adapters from toolkit D88P 19703B. Be aware that you can use any R12 manifold gauge set in good operating condition for vacuum testing all R12 and R134A components. While the service fittings for R12 and R134A systems do have different designs so the two refrigerants won't accidentally be mixed, we'll be testing an evaporator core using an R12 gauge set. An R134A gauge set cannot be used to vacuum test components. Note, the line fitting adapters from toolkit D88P 19703B only have quarter-inch flare fittings, which can only be connected to the R12 gauge set. Therefore, you must use an R12 gauge set when vacuum testing R12 or R134A components. It is imperative that the equipment used in this test be in good working order. If your test equipment can't hold a vacuum, there's no way you can perform an accurate vacuum test on the evaporator core. It's suggested that this equipment be tested weekly. To test your gauge set, connect the ends of the red and blue hoses together using a quarter-inch flare coupling or the correct size male and female test fittings from the test kit. Connect the yellow hose to a known good vacuum pump. Turn the vacuum pump on and open both gauge valves. Operate the pump for about 1 minute. And then close both valves and turn off the vacuum pump. The low side gauge should indicate approximately 30 inches of vacuum. Let the whole thing sit for at least 30 minutes. If it's still holding 30 inches of vacuum when you return, the gauge set is good. If the gauge readings drop during that time, either the gauge or the hoses are leaking and must be repaired or replaced before vacuum testing the evaporator core. Ford's Climate Control Operations recommend that your dealership keep a dedicated set of manifold gauge set hoses for AC leak testing. Before connecting the manifold gauge hoses to the evaporator core, inspect the fittings of the core for nicks or scratches which could lead to a leak. Before connecting the manifold gauge hoses, replace the line fitting O-rings with new green O-rings. Then apply a good coat of clean refrigerant oil to the line fittings. Now, using the appropriate test fittings from the adapter set, connect the red and blue manifold hoses to the two evaporator line fittings. And connect the gauge set's yellow hose to the vacuum pump. As an alternative to this double hose method, you can plug a line fitting that is particularly difficult to access, and then conduct the test using only the low side manifold gauge valve, turning off the high side valve. This may make the test easier, especially on vehicles where the evaporator core is positioned inside the passenger compartment. Then, connect the gauge set's yellow hose to the vacuum pump. Note, the automatic shutoff valves on some gauge set hoses do not open when connected to the test fittings. Use hoses without shutoff valves if available. If hoses with shutoff valves are used, Check to be sure the valve opens when attached to the test fittings before installing the fittings and proceeding with the test. The test is not valid if the shutoff valve does not open, because only the hose will be tested. Turn the vehicle's blower motor to low for the first 15 minutes of the operation. Open both manifold gauge valves and start up the vacuum pump. Once the low side manifold has reached 30 inches of vacuum, allow the pump to operate for a minimum of 45 minutes. This evacuation is necessary to remove any residual refrigerant left in the oil. After 45 minutes, close the manifold gauge valves and turn the vacuum pump off. Now check the low side gauge dial. The gauge should still read 30 inches. If the low pressure gauge reading never does reach 30 inches with the valves open and the pump operating, close the valve set and observe the pressure gauge. If the pressure rises rapidly to 0, a major leak is indicated. If the pressure gauge reading rises 10 or more inches in 10 minutes, a small leak is indicated. Wait another 30 minutes and check the gauge again. If a small leak is suspected, run the test again. If a leak in the evaporator core is verified, the core must be replaced. Always remember that a leaking fitting, gauge set, or hose connection will appear as a leaking evaporator core. If the evaporator is not the cause of the refrigerant leak, you'll need to continue the search elsewhere in the AC system. Again, we want to remind you that over 60% of the evaporator cores currently being replaced as defective in Ford and Lincoln Mercury dealerships are perfectly fine. Replacing the evaporator core is a time-consuming and costly procedure that more often than not does not resolve the problem. By making sure that your test equipment is in good working order, and by following the service manual diagnostic and test procedures carefully, you can increase Ford's customer satisfaction by making sure their cars and trucks are repaired expertly the first time they are brought in for AC service. If you have questions about this or any other climate control concern, call the Ford Climate Control Operations Hotline number at 1-800-451-9133.